In the previous lesson, I showed you an example of an SPA architecture for the sample SCED application. In this lesson, I'm going to dig in deeply and show you some of the code that goes along with it. Even for a relatively small application, there's a fair number of moving parts here. There's HTML, there's Python, there's JavaScript, there's Vue.js specific JavaScript, and Vue.js specific templates. I'm not going to go through all of that. For the most part, I'm going to concentrate on the server-side Python and some of the JavaScript. In particular, I want to highlight the parts where the DRF is interacted with, and then some integral parts of the JavaScript inside of the Vue pieces on the client side. The site you're watching this on, of course, isn't called Real JavaScript, it's called Real Python. So if you're not familiar with JavaScript, this could be a little bit painful. The expectation here isn't for you to understand every little bit and piece, but just to get a high-level view of how the parts fit together. Don't forget, all of this is available inside of the supplementary materials, and you can play with it on your own if it helps you understand. If you're going to run the sample code for yourself, you're going to need a couple things. First off, you'll need to install the dependencies. The dependencies are listed inside of requirements.txt. In order to keep your Python environment clean, it's best practice to use a virtual environment for this. You can install all of the requirements.txt file by using the -r parameter to the pip install command. This will take everything inside of the text file and install all of it. Inside of the SCED directory, you'll find a shell script that you can use to create the database, do the migrations, and set everything up. This is a bash shell script. It will only work if you are using some sort of Unix derivative. So if you're on a Mac, on Linux, or you're using the Windows Linux subsystem, then you can use this command as a shortcut. Here's the contents of that script. If you happen to be running on regular Windows and you can't use this script, then type these 6 commands in and you'll be good to go. Actually, you'll only need the last 4. Because if you've got a brand new environment, there won't be any PYC files or a SQLite file to get rid of. The first command, wipe migrations, comes out of Django all. It destroys any migration files. I use this command when I'm playing with a brand new project, so that I don't create overly complicated chains of migration history when I don't really care about the migration history because I haven't gone into production yet. So it starts me clean each time. Then make migrations and migrate will set up and run your database, and then load data is used to grab the sample data for the timelines. The first half of this script gets rid of anything that's there already, so if you play around and you want to start from scratch, run the script again. Let me show you what this application looks like in the browser before I show you the code. Off screen, I'm running the Django dev server, and here I'm going to hit the home page of localhost port 8000. Here's the first of my 2 pages of my single-page application. This one is a standard Django view that spits out a simple bootstrap listing of the timelines that are in the database. Clicking on Peru takes me into the second page of my single-page application. And this one's a little more SPA-ish. This is built with Vue.js. Each row in the schedule corresponds to an item in the database. All of the rows are being sent down via JSON, and then interpreted by Vue.js. I can click the Add button, and get a pop-up for entering new information. This pop-up is one of the Bootstrap modal pop-ups coming from that library that I told you about. The pop-up is REST aware. This form inherits from a base class that knows how to create things in REST. It uses the names of the fields inside of the form and populates an AJAX call up to the server with a post method. By doing this, I need very little code to be able to create new objects on the server. I just need the form to create them and to make sure that the name attributes of the form are properly set. Submitting the form does a call to the server and updates what's on the screen. Clicking on one of these objects pops up the same form. Now the same form can be used to do an update. The Bootstrap modal library takes care of all of this for you. Clicking the delete button brings up a confirmation dialog. These dialogs are also part of Bootstrap modal. If I click yes, then a JavaScript function is called calling this REST delete on the object in question. I'll show you the code to that shortly. And finally, this application is drag and drop enabled. The handles on the left-hand side of the screen allow me to change the order of the items. This no longer follows the movie, but you see what I'm talking about. The movement updates the rank of the item affecting the order on the server, and this has to be done with a custom action in order to take advantage of how ranked models work. Here are the models for the application. There's two things in the database. One, which is a timeline, which is named and groups a series of entries, and the other is the entries. Line 6 through 10 defines the timeline, and the entry object starts on line 12. Let me just scroll down here for you. The entry has 4 fields. 3 of them are defined here: title, length, and the timeline that's associated with it. And the 4th is hidden in the abstract model called ranked model. The ranked model contains a field called rank. This is an integer that is 1 or more and indicates the order of the entry. Inside of the meta class, I specify the ordering as the rank field to make sure that when these are queried, they come back in rank order. Here's the views file that defines the 2 pages in my single page application. Line 6 is the home page that lists all of the timelines, and line 14 boots up the single page application part of this single page application. The edit timeline view takes an ID, which is the timeline that is being edited, and then it renders the edit timeline.html file. That file, amongst other things, contains the information that view.js needs to render the page. Up until now, I've been showing you the core app, which is for the timelines. I've also created another app called the API. I'm grouping all of the things that will be available through REST inside of the Django API app. That includes the serializers.py file. Inside of the serializers file, I have 2 serializers, one for the timelines and one for the entries. The timeline serializer contains the entries within it, so I'm nesting entry objects inside of the timeline. Here's another use of the source attribute. The name entry set might be a little confusing inside of the HTML or for anyone who isn't familiar with Django. So I've changed the serializer to call the entries entries. The entry serializer then has the source parameter of entry set, telling the DRF that the entries field should be populated based on entry set of the timeline. Because there are multiple entries, many is set to true, and so that I can create a timeline without specifying and serializing entries to go with it, I've set read-only equal to true as well. The entry itself contains the ID and the URL of the entry, the title, length, and rank of the entry. It also contains the timeline field. This will be the ID of the foreign key of the timeline object. This is necessary because you can't have an entry without it pointing at a timeline. So when you go to create a new entry, you're going to need that timeline ID. Inside of the API views file, I define the view sets for the DRF views that I'm going to use in the application. The first 2 items here are the vanilla view sets for the timeline and the entry. I've specified their corresponding serializer classes and the corresponding query sets. Let me just scroll down. The abstract ranked model class has logic inside of it that ensures that the ranks stay in order. The logic of all of this is done inside of an overridden save method. The DRF does not call the save method on an object. It directly updates the database. Any logic in an overridden save is not going to get executed. As a result, I've defined a new view here that is specific to changing the rank. I'm not going to use the built-in update methods of the DRF. I'm going to update it myself manually to ensure that the entry's save method gets called. Except for this being a special case as to why I'm doing it, the rest of it is a view like you've seen before. I'm using the API view decorator to indicate that this is a get. This is a little hackish. To be more technically correct, I probably should have made this a put or a patch because I am editing an entry. But the URL that I'm going to be using for change rank will include the ID of the entry and its new rank. And because I'm doing this inside of the URL, I'm sticking with a get. This is one of those many cases where REST is kind of a suggestion rather than a rule. Using the entry ID, I get the object. I change the rank to the new rank provided and call the overridden save. I then requery all of the entries that are associated with this timeline and serialize them, sending them back down. This means when a move has been executed, the view application can get all the data at once as to what the new ranks are of all the entries that were affected. This is part of the Edit Timelines HTML file. The script body block is where all of the JavaScript pieces get set up. The key to interfacing with the DRF is passing a URL that specifies the timeline REST API action point to the view code. I've done this through the URL tag when this page gets rendered. The tag returns the timeline point for the REST view and sets that URL inside of the JavaScript global variable fetch URL. The Vue.js application will then use this to fetch the payload and populate the page. The remainder of this block is the loading of a variety of JavaScript files, including those to do the Bootstrap modals dialogues, a utilities function that deals with CSRF prevention, the actual Vue.js application inside of timelines.js, and a third-party library that allows me to do drag and drop with Vue.js. This is the timelines.js file. This is where the master object for Vue.js is created. That's on line 4, and it's put in a variable called VM. You'll see the use of that variable throughout this file. In lines 8 through 11, I create the data for the Vue.js object. Has loaded is used to indicate whether or not the screen should be rendered yet. Timeline ID, name, and entries are all the JSON that come from the server. Timeline ID and name being from the timeline object, and entries being the array of JSON that specify the entries on the display. Django has a whole bunch of security mechanisms built in, one of which is to prevent problems with form posts. This is done through the CSRF token. The AJAX setup and getCookie methods come out of the utilities.js file and are used to make sure that a post can happen. All Django posts must include a CSRF token, so this little bit of code gets that token in the right place. Once everything's loaded on the page, the last call here is to refresh view. This method is what actually does the REST call. Inside of refresh view, I use jQuery's getJSON method, passing in that global fetch URL variable. GetJSON takes a response function, and inside the body of that response function, I'm setting up the Vue.js data attributes. Timeline ID and name both come out of the response field from the timeline object, and entries is copied from the array of entries. Once those three values have been put inside of the Vue.js object, I set hasLoaded to true to get the screen to render. The Vue.js template that is rendered included the add button. There's a hook on the add button that says when the button is pushed, call the method addEntry. That's defined here on line 14. Inside of the add entry, I create a dictionary that contains the ID of the timeline object for the entry that's being created and a rank. The rank is set to be one more than the last rank currently in the listing. The Bootstrap modals library has a way of declaring forms and using REST methods to update objects that are associated with them. In line 22, I'm using the change form, which you saw that was popped up when you hit the add button, and I'm calling the showCreate method on this form. ShowCreate knows how to talk to REST using a URL, doing a post, creating a new object. The first parameter to this method is the URL of the posts, API v1 entries, because I'm creating a new entry. The second parameter is the default data for the dialog box that's being popped up. The dialog has two hidden fields, which are the timeline and the rank, and then the two fields that you saw, the title and the length. That populates the dialog box. When the user hits save, the server is contacted by the Bootstrap modal library, the REST post is done, the object is created, and then the third parameter of ShowCreate is a callback. The response contains the newly created object. vm.entries.splice is a way of taking that response object and gluing the result into the entries listing on the view.js object. This adds the newly created entry to the list on the screen. Edit entry works in a similar fashion. Once again, using the same form, this time calling a method called showPatch. ShowPatch takes the URL of the entry that was passed down as included as part of the JSON payload, the entry object itself, which it uses to populate the form, and then when the user hits OK in the dialog box, a patch is issued to the server. The REST code is triggered, the entry is updated. The third parameter to showPatch is once again a callback. Once the entry has been patched, the server responds with the updated entry. The view.js VM object has the entries array spliced, replacing the old entry with the new one that was just edited. You saw on the screen that I'm using a third-party library for view.js called Draggable. The Draggable library comes with its own tag, and inside of that tag I have specified that when a drag action completes, that this method entryMoved gets called. You'll recall that I don't want to just call patch here on the rank number because I need the object's save method to get called on the server. So I'm calling a specific custom REST action instead. I do that by using jQuery's getJSON. The URL is the change rank URL that I showed you earlier, complete with the ID of the entry that's being changed and its new rank. And getJSON has a callback. And I take all of the entries that come back from the change rank and replace the client-side copy. Similar to the add button, each delete button is also wired to a function. That's this delete entry method. Inside of that, I'm using another dialog box out of the Bootstrap modals library called confirm. Confirm shows a title and whatever text you give it and presents a yes and no button. Then it has a callback mechanism that checks whether or not the user hit yes or no. On line 52, I look for a negative result and do nothing. The REST call happens on line 56. If you get here, then the person hit yes. It takes the entry object on the client side, grabs the URL, and does a straightforward AJAX call using HTTP delete on that URL. The object has now been deleted on the server side. There were a lot of moving pieces in that. I hope it wasn't overwhelming. My intent was just to give you a flavor of how the REST pieces can be used inside of a single-page application. If you're truly interested in how all those pieces work, you'll probably want to dig into the sample code and walk through it yourself. Next up, the last lesson, summary of everything you've learned. In the previous lesson, I showed you a sample single-page application. In this final lesson, I'll summarize what you've learned. REST is a loosely defined protocol that allows you to list, create, update, patch, and delete data on your server. It uses existing HTTP methods and URLs to perform the actions. The Django REST framework, or DRF, works in conjunction with Django to perform REST activities on top of Django model objects and views. Inside DRF, the serializers are responsible for turning your data into payloads and taking payloads and turning them into your data. The model serializer maps Django ORM objects, This means it takes very little code to convert something you've already got into a payload. Objects with relationships on the server side can be serialized together and nested into parent objects. Although the most common use of serialization is to serialize Django ORM objects, DRF serializers are able to serialize generic Python classes. You can pretty much serialize or deserialize almost anything that you want. You implement a REST endpoint with a view on the Django side. The DRF provides decorators to wrap your views and REST response objects that know how to work with the serializers. In addition to the views, the DRF provides a series of classes called view sets. These classes group together multiple HTTP methods or REST actions and manage them together. This is particularly useful when you're serializing a Django ORM object. You can create a view set that has all of the REST action points for that ORM object in just a few lines of code. You can create a DRF router object to register one or more view sets, and it will automatically map that view set to the necessary URL patterns. You can manage who sees what data and what they're allowed to do with it by specifying permissions and query sets associated with a view set. You can also add custom actions to a view set in order to augment the base REST calls. The DRF response object takes information out of the serializer and turns it into a payload. It does this through a renderer. DRF supports several different ways of rendering your data. By default, it gives both a JSON and a web-based interface for your payloads. You can also control which renderer is being used and how things are rendered through changing settings or decorators of your views. For further reading and minutiae on the DRF, go to the Django REST Framework website. The website also maintains a huge list of third-party packages that may already implement that corner case that you've been worried about. Take a look at this URL for more information. I hope this course has been valuable to you. Thanks for your attention.